Hi, I'm Allison from Thronateeska Heritage Center, and today we're going to be talking a little bit about stars. Now, if you've been outside, either at night or in the daytime, you've probably seen at least one star out there. Believe it or not, but our sun is actually a star. You may have heard some people say that it's this big ball of fire, and that's not exactly true. What's going on with the sun, it's not on fire. It's going through a chemical process called fusion. And what's happening there is in outer space. Just imagine for a moment, you're floating around in outer space, everything is fine, it's great. You just see these big clouds of gas and dust floating around out there, and over thousands, hundreds of thousands, millions of years, they gather together and they start to just cluster up together. The more they gather up together, the more gravity pulls more of it up together, and it just pushes and pushes and pushes, and it just eventually smashes it together just so fast. Like, you can't even believe so fast. It kicks off this process called fusion. Gravity just smashes all those elements together, and that force, that energy, starts them scrambling up together, and they actually change from one element into something completely different, and that process is called fusion. Now, in the course of that process, it releases all sorts of energy: X-rays, gamma rays, visible light, what we see when we step outside during the daytime, daylight, that's coming from the sun. That is some of the energy that's being released from that fusion process. When we feel the heat from the sun, when it helps the plants grow, when we get a sunburn, that's energy from the sun coming from that fusion process. So there's unbelievable energy coming out of that process. Now, is our sun a star, the biggest one out there? Definitely not. Just for point of reference here, if this were the biggest star out in the universe, our sun, you would not even be able to see. It would not even be this little fleck of glitter that's forever stuck on this beach ball. Our sun is so tiny compared to so many of the other stars out there in the universe. It just seems biggest to us because it's the closest one to us. Now, I say it's the closest one to us. It's not actually that close to us. I mean, relatively speaking, it's kind of close. It's actually 93 million miles away. And space is so big that astronomers actually have to use that distance as a ruler in outer space. They call that an astronomical unit, or an AU. Is 93 million miles. A yardstick, a ruler, it's not going to get you very far in space. You need something that's 93 million miles long to get you anywhere in outer space. So we use that distance there. Now, so we have our star, we have the sun. It's made through hydrogen and helium, these other chemicals floating around in space. Now, are all stars the same? We saw with the beach ball, some of them can be huge. How does that happen? Well, you have the way stars are born, if we go back to their origin story, is you have in space those clouds of gas and dust. They're just kind of floating around, getting super artistic there, can you tell? So we have these clouds, and those are called nebulae. Forgive my handwriting. So we have these clouds, they're nebulae. Those plus gravity, and you get your star. Poof, there it is. And it's going through fusion right there. Now, depending on how much and what was in this cloud determines what you get on this end of things. If there was a lot of helium, a lot of hydrogen, just so much of this stuff over here, then the star that you end up with in that process is going to be one of the giant stars that you hear mentioned that turn into things like black holes, which we can come back to, or they explode in supernova. You may have heard about those. And that supernova turns back into a nebulae, and you just kind of go in that cycle all over again. So that only happens with those ginormous stars that we can't even imagine how big they are. They're so huge. Astronomers have calculated how big they are, but it's really hard for us to actually understand. But you can check out NASA's website, nasa.gov. They've got lots of good information there and good graphics to help illustrate just how big some of these stars actually are. So you've got the supermassive stars. Supernova is when the star just poof, explodes. And you've probably read about some of those in history, different supernovae throughout history, where you suddenly just have this bright light in the sky that only lasts for a few days and then it fades away. That's your supernova. So we have those. Now a black hole is when a star, when there's so much gravity, it just can't handle it anymore. It actually squishes the star down in on itself. It almost turns it inside out. It's really weird. Scientists and mathematicians are still trying to figure it out. They still argue about it a lot, but it's kind of like the star's inside out, and it's pulling things down into this whirlpool in outer space that's going somewhere but nowhere, and it's kind of, it's hard to understand. They're still trying to figure out, and it makes it all that much harder because we can't see them. All we can see is what's happening around them because it's pulling things in this big wide wild orbit. It's sucking things in and shooting gas back out, so we see all this crazy stuff happening and there's just a blank spot in the middle of it. It's really weird. So that's pretty cool. Hopefully some astronomers someday will figure that out, but that only happens with those supermassive stars right there. Now our star is not one of those. Our star is one that's actually kind of in the middle. It's just a main sequence star. It's just a yellow star, very, very small in the scheme of things. It's probably going to stay about this size for millions of years. Over time, it will swell up and just start to slough off its gas over time. If you've ever seen a snake shed its skin, it's kind of like what it's going to do. It's just going to get bigger and bigger and bigger, and then it's just going to and burp out all this stuff out into space, and then you're just going to be left with not very much after that. But that's going to happen millions of years from now. It's going to take a very, very long time for our star to reach that point. But once it does, it's going to swell up so big, it's going to eat Mercury and Venus and come very close to Earth. That's going to be millions of years from now. So that would be the main sequence star. But other stars, sometimes you get just your little dwarf stars, your little red dwarf stars. They're not going to do anything. So I didn't draw with that one. They're going to poof up and then shrink back down. Then you have these, your dwarf stars. They're going to stay that way forever. Not a whole lot of change. Now these stars actually have a lot of metal in them, believe it or not. A lot of iron. Some of them have calcium in them. So these don't have so much gas. It's the more gas a star has in it, the bigger it's going to be. If it doesn't have as much gas, it's going to be one of these smaller guys over here. But even with all of that, as these are floating around in space and doing their thing, it's all a cycle. And it's all just, they're going to kick off into fusion, either grow, shed their stuff, they're going to start, they're going to go into black holes, and then they're going to start redistributing all of that material back out into space as they suck it in and blow it back out. It's just all a cycle. It's all changing, never going to end that way. Thanks for stopping by. My name is Allison from Thronateeska Heritage Center. This has been another science short. If you have any questions or comments, feel free to leave them in the comments. We'll be sure to get back to you. And check out the links in the video description. We'll have more information there. Again, just stay safe, cover your cough, wash your hands, be smart people, take care of yourselves, and thanks again.